everyone, my name is Amel Sellami. I'm from Tunisia, a small country in the north of Africa. So today we'll talk about TensorFlow on Google Cloud Platform. I'm a Google developer expert in machine learning, a research engineer at Anstudy, and you can find me on Twitter via the handler DeepLearnWizard. So previously, this presentation was done by Carl Windmaster, who is a developer advocacy manager at Google. I just got it and changed quite some things in it. So before perhaps starting a few key points, I'm from Anstudy, as I said. So Anstudy, the company I work for, was founded in 2015. The team is composed of 108 RR AI engineer, software, hardware visualization team. So we have offices in Tunis, London, Paris. In general is deep learning, the deep learning book by Ian Goodfellow, who is one of the founders of the generative adversarial networks, if you have heard about them. If we're more interested in reinforcement learning and all this kind of stuff, An Introduction by Saturn is also a good book. There is also YouTube links like Deep Learning Without a PhD by Martin Gorner. You can also find online classes from Coursera, Udacity, and there are a couple of kind of platforms that helps you learn while meeting incredible people in the AI community like Kaggle or Zindi for Africa. So, and there is also Fast.ai, which can bring PyTorch kind of applications into the world. Okay, the first thing that I wanted to try before diving in the Google Cloud kind of things with TensorFlow is that the ML pipeline is basically we have like the data and streaming. We try to get the distributed data storage and streaming, like for example from Google Cloud Storage, HDF5, and all of these kind of things. We try to pre-process and analyze the data that we have using Jupyter Lab, Jupyter Hub, Spark, Apache. Lots of frameworks, like for example TensorFlow and PyTorch, helps us build models easily and then train them, whether locally or on any kind of platform. It could be Google Cloud, it could be Google Colab, or any other kind of things. And basically, there are two types of machine learning kind of problems. Let's say the first one, when we try to do more or less research with it, try to find new architectures, hyperparameters, give new insights to the machine learning community, or more or less trying to do machine learning for production. And some kind of production, we use it basically every day in our lives, like for example advertising, or trying to find I don't know, traffic jams when you try to monitor the traffic jam, to monitor any kind of, for example, for video or image analysis, and all of these kind of applications. So it depends actually what you want to do. And basically, we try to use Google Cloud Platform for basically production kind of type machine learning problems. So why do we want to use Google Cloud Platform for machine learning? It could be basically we can use it locally, right? If you're having like small data, what we call is pet projects or toy projects, where you have the data and this data is small, you can use it with your just one GPU or your two GPUs on your local machine. But it's not the case when we want to do something for production and give customers and clients insights and get insights from these data that you can get out there. So basically, one of the pain points in machine learning problem is that the data needs distribution and chunking. By distribution and chunking, we mean that big data and lots of data, when it's getting bigger, it's really hard to do this on small machines and local machines. TensorFlow help us in doing the distribution of the data and streaming from it and chunking it. It also help us in the feature engineering part, for example, for data scientists or ML researchers. And one of the other things that TensorFlow and Google Cloud Platform help us is that we train, the training needs, we need to experiment with variety of different models, architectures, or hyperparameter tuning. That's why we try to use Google Cloud Platform, because when you want to test different kind of models for the same problem, it's very hard to do it locally and offline. Another important thing that we must say is that this is not just true for data scientists or ML researchers, it's also true for when you want to auto-scale. For example, we have more clients ranging from 0 to 10,000 clients. You just need to use an API call or any device with any language that you have, for example, Java, Python, or all these kind of things, and it's able to help you create these kind of models. So how to use Google Cloud Platform to serve these models into production? Basically, on Google Platform, it provides multiple ways for deploying inference in the cloud. So one of the three major things are compute engine cluster with TF serving. The other one is cloud AI platform predictions.
Amel, can you
is there anything?
Sorry for interrupting.
Yes. Yes.
So we can only see your first page of the presentation. Yeah. So can you check?
Okay. Okay. I think it's related to. Okay, can you see it now? How about this? Okay, I think I'll just leave it this way. You can see my.
So we can see it now. We just want to warn you because we only see this page. So if you're talking about here,
okay,
it's fine. Okay.
Yeah, I was saying the. Well, basically, these are the learning resources. I'm not sure if you saw them or not. This is the machine learning pipeline. And this is why we use machine learning problems, as I said. And I was into the Google Cloud and how to serve models. If there is anything that you don't understand, I can get back. If everything is clear, I can carry on. What do you think?
You can continue. It's fine. It was understandable. We just want to warn you because this presentation is so fine.
Okay, cool. So what I was saying is that Google Cloud Platforms provides multiple ways for deploying inference in the cloud. So basically, what we use is compute engine TF serving, cloud AI platform predictions, or cloud functions. And typically, basically, for cloud AI platform prediction, use it with TensorFlow or scikit-learn kind of models. We don't use it. PyTorch for now is in the beta mode. And yeah, so these are the three kind of ways to deploying inference in the cloud for machine learning models. So for TensorFlow serving, we use a cluster as an inference for the model, the TF serving, as we said. What we do is we organize inference on one or more of the virtual machines. After we add a load balancer on top of the cluster, as you can see in here. The second, this approach is that has some kind of advantages. The first one is you get response time as the model will be loaded in the memory. And it's an economy of scale, meaning that the cost per run will decrease much when you have a lot of requests. Typically, we use cluster TF servings when you have production-ready kind of machine learning models. And these production-ready we're going to access them in real time for 27 hours, 7 days a week. This is the kind of things that you want to use when you have this kind of architecture or this kind of problem. The other one, as we said, is the cloud AI platform, which is AI platform predictions. So it has lots of advantages. One of the things that it's really important to say that we can use AI platform serving with the cloud functions, but I'm not going to talk about this in this presentation because it's not in the scope of work. So so the advantage for inference when it's compared to the cluster or the TF serving is like it's codeless inference, makes getting started easy, scalable infrastructure, no management of infrastructure required, and you have separate storage for the model, which is convenient for tracking versions of the model and for comparing their performance. Typically, when you do machine learning, as we said before, you want to try different kind of architectures. And these kind of architectures, it depends on different kind of things, hyperparameter tuning and all the things that we use in machine learning. That's why I think it's really, that's why one of the reasons to use AI platforms is to try two different models and try to compare them. AI platform predictions make it easier for you to do this kind of versioning of the models and comparison between them. One of the things that it's important to say, you can use in the AI platform predictions TPUs, GPUs, and CPUs as you can desire, and it's pretty much not hard to use. The third one that we are talking about when we try to do serving a model on Google Cloud platform is that we have the advantages are Google Cloud provides some free invocations of the cloud functions per month, which is basically would be perfect for a pet project or a toy project, a small kind of project for a startup that wants to get early custom access for feedback on a prototype or something. You have a simple code for implementing the inference, which at the same time allows you to implement custom logic, great scalability, ranging from 0 to 10,000 K almost immediately, and cost structure, which allows you only to pay for runs, meaning you don't pay for the idle services or the other services that you use while trying the model. And the ability to use custom versions of different frameworks, TensorFlow 2.0 or PyTorch, as you say. Okay, so this kind of table shows the different kind of three platforms, the best part of them, the things that you want to use, and all these kind of things. Because basically, when you're going for a model, when you're going to use a model in Google Cloud Platform, you're going to ask yourself, what do I want? What do I need? What is the model that I'm going to use? And all these kind of things. For example, if your end goal is just something for experimentation, you're going to use cloud functions because it's lots cheaper. Because Google Cloud Platform is obviously a pet platform. If you're, for example, for production, you can use Compute Enter or AI platform predictions. If you're for scalability, basically the three of them are scalable, but with the AI platform having to do for extra configuration with it. If you hate, for example, infrastructure management and you don't want to do that, you just need to use the AI platform predictions. So actually, it depends on what you want to do and how you want to do it. Okay, so what we're going to talk about to dive a little bit more is the second one, which is cloud AI platforms. And we're going to use the TensorFlow on Google Cloud Platform. So when we say TensorFlow is a popular open source machine learning framework with an end-to-end support on Google Cloud. And this presentation we're going to do, it shows how to get started in hands-on way. So basically, we'll talk about TensorFlow Enterprise, the virtual machines, and the notebooks as the infrastructure that you're going to use for training, and then serving, and then explaining your model in this kind of machine learning algorithm. So first of all, when we say the cloud AI builder tools, it depends on the level of automation that we have, whether it's high or low. So basically, there are ML infrastructure, AI platform, cloud AutoML, and API pre-trained models, and it depends on what you want to use and what you want to do. So basically, as I said, we'll focus on the AI platform. Just to a small kind of pipeline for our model using the AI platform is you do the ingestion, you pull in your data streaming, you analyze your data, then you transform it in feature engineering and all this kind of stuff related to data sets. And then you do the training, whether with AutoML, custom code, or trained outside the cloud AI. and then you do the tracking of your model, you do your evaluation, and then you have your deployment, which is the endpoints could be on endpoints or batch predictions. So this is the big picture of the AI cloud AI platform. And what to say is that TensorFlow, in a nutshell, is an open source deep learning library where you have, it was released by Google in 2015. Actually, it was a research paper. And in 2019, the TF2 was released, which is much easier. If you're more interested, there's also a new version that was released 2 or 3 days ago, if I'm not mistaken, the TF2.4. And if you're for more tutorials or community stuff, there is TensorFlow.org's tutorials or blog TensorFlow's Twitter and YouTube. The ecosystem for TensorFlow, we use basically Keras, which is the high-level APIs for beginners and experts. And we can use like TensorFlow.js, Lite Micro, or Serving for deploying models using a REST API that we'll talk about later. And there is also Swift for TensorFlow. So just a quick overview about TensorFlow Enterprise, which is basically a cloud scale performance. It offers you cloud scale performance, accelerate and scale your machine learning workflows on the cloud with optimized performance. It also helps you manage services, like deploy and develop TensorFlow across managed services in the Google Cloud. And there is enterprise grade support. It's a long-term version support on Google Cloud, meaning that you can have patches and bug fixes backported in your project. And this is actually, sorry, for at least, let's say, 3 years in a row. Okay. The second thing that I wanted to talk about is the deep learning virtual machine images and the notebook. So as I said earlier, one of the user pain points in data sciences and machine learning, also apart from the one that I've talked about, our installing framework is very hard and the reproducibility is harder. What I mean by the framework, installing framework is hard, is that deep learning libraries have a vast network of dependencies that make them hard to install. This is why the solution we're going to get it later. And also reproducibility, which is differences in how users set up their development environment, can affect how reproducible this code is and how easy it is to move to production. So one of the solutions, the solution to use here is using the DLVM, which is deep learning virtual machines. For example, use a Debian 10 images for key deep learning frameworks optimized for GCE hardware with a wide array of libraries pre-installed. So just a basic virtual machine on the Google Cloud. But we can use how to create this virtual machine using the command line. You just need to say cloud compute instance, create my instance. You use the zone that you specify. Specifying the zone, it depends on where you are and how costly it can be. So it's another topic. And image family, we use the TF2 latest GPU and the image project, which is deep learning platform release. You can use the CPU and GPU images available and can also specify versions. Okay? So as I said, we're going to talk about the virtual machines and the AI platform notebooks. These are the two things that can help you train and then deploy your model. First thing is, what is AI platform notebooks? A hosted Jupyter notebook solution that makes it easy for data scientists to spin up the Jupyter Hub, and it gives DevOps kind of controls they need. Well, for example, you don't need a learning curve. It's like using the standard Jupyter Lab inference that we use. It's scalable and cost-effective. It's centrally managed, and you have the Google Cloud Platform integration. And it's easily built, trained, and deployed, and deploy models. You can use this on it. So basically, you just want to do the runs on the deep learning virtual machines using for example, PyTorch or TensorFlow. It depends. So it's just one-click deployment. Like you spin up a Jupyter Lab instance and then pre-configure, which is pre-configured with TensorFlow. But how am I going to create a notebook like this. Just a simple command line like this is sufficient. You just need to say Google Cloud Beta Notebooks, the notebooks that we're going to use. You do the instance, you create my instance, you decide your location, you use the virtual image family machine, and then the virtual machine image project, and then you mention the machine types. There are actually different types of machines, but basically the most famous one is, or the most used one is the standard machine. It's just a machine that you're going to use with GPUs and CPUs cores in it. So after like having this specific kind of architecture, we're going to train our model. And to train our model on cloud AI platforms, it has quite some advantages, as we said before. And as we said, it's serverless training with AI platform. You don't need services. And basically what you're going to do is train your model without managing infrastructure. If you don't want to do infrastructure, this is a good thing. So it supports TensorFlow 2.x, and it leverages distribution training on the latest GPUs and TPUs to finish the job faster. And what you're going to do, you can also improve your model quality with automated hyperparameter tuning that we are going to see next. And how are we going to do that? But first things first, how am I going to train a TensorFlow model? Basically, it's just a Docker user journey. First, you're going to develop a TensorFlow model and training code. You create a Docker file, you build the image, you push it to a container registry. Like, for example, it could be Google Cloud container registry, and then you kick off your AI platform training job. Okay? So, as we said, first we create our model. This is our model, a typical machine learning model using Keras. You have your model, you have your TensorFlow, which is the Keras, a sequential model, basically. It could be with an input 100 and the output 1. We have our activation, which is ReLU, the input shapes, and all these kind of things. This is built in a file. We named it model.py. And also we have another one, which is task.py, which is the task that we're going to execute later. And the task.py is just executing the training of the model. With basically, when you train your Keras model in TensorFlow, you just need to do Keras model.fit. This is our model. We're going to train it later. And you give it the kind of hyperparameters that you want to change or do. For example, here steps per epoch, the validation data, the validation steps, and all these kind of things. Well, you can find the coding structure in Cloud Amel Simple's repo if you're interested. The second thing, as we said, we are going to create our Docker file. So our Docker file has an extended deep learning virtual machine image. We have the work directory. We just create a model, then task, the model.py and the task.py that we copied them from our the one that we have created, and our entry point is just to execute this the file, which is task.py. After creating the model, now we're going to build, test, and push the image. First of all, we build a Docker image normally, like we build any Docker image, and then we test it locally. It's really important to test locally before you test it on Google, before you deploy it on Google Cloud. Why is that? It's just to push it on Google Cloud. Why is that? Because when you test locally, if there are any kind of errors, you try to find them, and you won't be built, because it's you're basically going to try with this method to help don't lose money. And the other thing is you can pass custom model parameters, for example, the learning rate, as you can see in here, into our image. All you gotta do after doing this run, after testing locally, building the image, you just push the container to the registry. And finally, what you're going to do is to submit the training job. And to submit a training job into the AI platform that we are using is just Google Cloud AI platform. The jobs that you want to do, submit the training, my job. You just try to find the region that you want to use, the master image URI, sorry, and then we have the learning rate that we have passed during the that you have created. The dash is just to separate the model, the parameters of the command line from the parameters of the model that we are using. Another hyperparametering kind of optional thing is to do hyperparameter tuning. For example, in the test.py, we just add a parser, and this parser, for example, in our case, we use the learning rate, and this parser is going to be to get it from the config.yaml that we have to create it in here. And this will help us and do some hyperparameter tuning when creating and then comparing after the models. We'll see how we're going to create two versions of the same model, for example, using hyperparameter tuning or any other kind of things. So what you find in the console is something like this. You have your job, you submitted your job, and then in Google Cloud you can find something like this. And as you can see, this job was created in 15 July 2020. So you can find all the kind of information that you want to use in here. Okay, so what we have done is that we prepared our setups. We created our model. We pushed our model. We have like a job ready for it. Now we're going to serve a model, but how are we going to do it? So one of the things that is important to know is that with AI platform prediction, it's really robust and reliable when doing the model hosting. So for example, you serve online endpoints for low latency predictions, or you do predictions on massive batches of data, meaning that it's very immediate when you do predictions on AI kind of platforms, whether it's on batch of data or endpoints. And it scales automatically based on your traffic. And you have log predictions, requests, and responses to BigQuery for monitoring, for example, or debugging. And you can choose a wide variety of compute kind of options, including the inference optimization that we use in, for example, NVIDIA T4. It could be also a K18 that we can use in this kind of GPUs, which are really powerful kind of GPUs models. So how are we going to serve a TensorFlow model? First of all, we create an AI platform prediction model. You create a version of the model with the trained model binaries, and then you make predictions. It's 3 steps. So the first one is deploy the model. First of all, you export the model binaries from the training job. So for example, you have here the job directory, you export it, and then you have the model binaries. So these binaries are from the training job that we have done previously, as you remember, after training our model. You create a model on AI platform using Cloud AI platform models, create a Keras model, we named it Keras model, and you can decide the region. And now we're going to deploy the model to the prediction service. When deploying our model, what we're going to say is we create version 1. This create version 1 meaning this is the first version that we're going to test. And it's based on the Keras model that we have done. And the origin from it is the model binaries. So for example, if you want to change the version, we just need to create another version, use another model's binaries, and so on and so forth. Then after creating the model, we make the predictions. And for making predictions, what we're going to do is, for example, we have this simple data JSON. We run an online prediction. We give it like Cloud AI Platform predict -- model Keras model, and then the version that we have specified, and we give it the simple data that we have. We run on an online prediction on our data. It could be one entry point or a batch prediction model. And with this, you can do it like you just need to give it the input and the output path to make the difference. And this is one of the best things about AI platform. And the third step, as we said, is to wrap everything with the REST API. This REST APIs will help you later on into using different kind of languages. For example, it could be used in Python, or it could be used in Java or any other device kind of or language that you want to use. So the REST API will wrap everything up and will help you with HTTP request to just give the predictions to a client if you're having, for example, 100 clients or 1,000 clients at the same time. Okay, so basically what we've done, we trained our model, we have served our model, we deployed it, and now we're going to try to explain it, because basically in deep learning models, the typical kind of vision to do it is that we train our model and it's great, the accuracy great, everything is great, you want to deploy it. The other way is I want to explain why things happened and how am I going to improve my model. And this is the part of explaining a model that you can use on Google Cloud platforms. So explanation on AI platform is typically when you have your request prediction on AI platform, AI explanations tells you how much each feature in the data contributed to the predicted result. You can use this information to verify, for example, that the model is behaving as you want it to behave. It recognizes bias in your model, gets idea for ways to improve your models and your training data. And all of these kind of things is that all the data that you can imagine, for example, interpret tabular, text, or image kind of data, it supports two explanation methods, and it uses the what if tool. So basically in here, as you can see, these pixels are why the model chose this picture to say this is a dog, not a cat. These pixels help you understand the reason behind why the model behaved in a certain way. The what if tool is just a tool that helps you wrap everything and understand. It can be used on Google Cloud platforms, Jupyter Labs, and all these kind of things. It's just like a tensor board or TensorFlow, tensor board kind of architecture to help you understand and explain things. So basically, an explanation on AI platform, this is how it works. As I said, you just build an image, text, or tabular model in TensorFlow. You deploy your model, as we said, to AI platform via Google Cloud or the API. You just want to do surface predictions to end user with the AI platform predictions API, or you want to debug your model into a notebook using the attributions for the AI platform and the what if tool. So basically, the supported explanation methods are, as I see in Google Cloud Platform, are all in TensorFlow. So basically, integrated gradients, Shadey, or Xerai. For example, this one, it depends on the data type that you want to use. This is one of the reasons on how to which gonna kind of problem you're gonna use, and you can know more about them if you're interested in their paper. So to deploy explainable models on AI platform, this is how you use it. You just do vCloud Beta AI platform versions. You create the version that you want, the model that you have, the framework, for example, and then the machine type and the explanation method that you want to use. For example, in here, use integrated gradients. And then you deploy the explainable model on AI platform. But what if I want to get an explanation on AI platform models? All you have to do is just Google gCloud Beta AI platform, explain to me the model that you have, that I have, with the version, with creating the version, and this is my data that I have. And this is how I get the explanation on a certain kind of model. So the explanation JSON that I get is something that looks like this: the attributions, the data, the example score, and then the output name, the durations, and the baseline score. Just a quick view on how to explain things is that when you get the name here, you get the features, you get the attribute value. So basically, if you say, for example, the one with the feature value the highest is the one with indicates the most important feature. And here it says the attribute value is meaning that the negative attributions means the feature pushed our model predicted durations down, and vice versa. All of these attributions are relative to the baseline prediction model. Okay, great. Thank you. I hope that it was somehow clear. Well, I did have jumped up into.
Hi, Amel. Thank you for presentation.
It was a great
I tried my best to just try to fit everything. There's lots of other important things that we can use, like for example, the pipelines and all these kind of things, and TPUs and GPUs, how we to use them on Google Cloud platforms. But I didn't find that this could be a very use time because we only have 30 minutes.
Yes, but it was a super cool topic. Thank you a lot about it. And today we have six speakers, and you are the only one, which is a woman. So special thank you for you. Thank you about it for inspiring us, actually.
Yeah.
Thank you. I hope everyone learned something new, and you try to dig more into machine learning and all this kind of stuff, because it's where the world is going nowadays. So yeah.
Yeah.
So, and if you want to also have another session later, so you can still keep catch up with us, and we can also plan another meeting. It will be super good. Thank you a lot.
Okay. Thank you. Have a nice day.